Hi everybody, and welcome to the video for evaluating expressions. So in this video, we're going to go over how to evaluate a multi-term expression using the correct order of operations. We have to be able to do this in order to have the skills to be able to evaluate functions later on. And you'll know you're successful when you can evaluate a more complicated expression like 6x to the second, y to the third, minus 2y plus 4x using given inputs like x is 3 and y is negative 2. So, again, you can pause if you want to write this down, but for expressions, remember that expressions are multi-term strings of addition and subtraction. A quick example of this would be the expression 2x minus 1. I have a variable with a coefficient of 2, and I am subtracting 1 from it. Expressions can have any value depending on what the variable is replaced with. So, multi-variable terms. Terms within the expression can have multiple variables. When this is the case, the mathematical notation is telling us to multiply our variables sequentially. So, thanks to the commutative property of multiplication, we can multiply the variable amounts in any order, so long as we do any exponentiation first. So, the example is 6x to the second, y to the third is a multi-variable term. And so long as I take x and take it to the second power, and then take y and raise that to the third power, I can multiply them in any order, and it will always be correct. So, evaluating. Mathematical evaluation means to substitute given values in place of the variables and then simplify the result as much as possible. Sometimes you may be given the final result for an expression and asked to find the value of the variables that produce that result. There is a difference in wording if that is the case though. So I'm just going to jump right into some examples. I've got like 2 examples per page, just rapid firing through them. So I'm going to just do this quick and easy, and we're going to get through it. So, first example, p to the second power plus m, use m equals 1 and p equals 5. So since that's the case, I'm going to substitute a 5 here. When I do my substitutions, I like to do them with parentheses all the time. It preserves negative signs. It's very important to preserve your negative signs here. So you're going to do 5 squared plus 1, and you get 25 plus 1, which is 26. Okay. The next one. P to the third plus 10 plus m using m equals 9 and p equals 3. So we're going to go ahead and, again, use parentheses to preserve everything that needs to be preserved when you make evaluation substitutions. So you have 3 to the third plus 10 plus 9. I know that putting the 9 in parentheses seems kind of redundant in this case, but again, I'm just doing it so that you form the habit that I have, which is to always put your substitutions in parentheses. So if you take 3 to the third, that's really taking 3 times itself 3 times. So this is really the equivalent of saying 3 times 3 times 3, which is 27. So 27 plus 10 plus 9. So 27 plus 10 is 37, plus 9 is 46. So the final the final evaluated result is 46. And so just a word of caution here, guys, we're not solving. Okay, this is not solutions. We are not solving anything here. We are evaluating. So we have 3 different terms so far for different types of mathematics. That we do with expressions. We have evaluating, which is what we're doing here. We simplify expressions. And we solve equations. So for evaluate and simplify, these are for expressions. Solving is only for equations. So that's just a little side note. Make sure that you understand the terminology behind this because it's incredibly important to know this going forward. All right, moving on to some other examples here. More examples, and these are a little more complicated. So sometimes you are going to find that some of these expressions get a little tough. So I picked out some harder ones that I could find, and put them up here so I could give you a good idea. So this one says y minus z plus z squared using y equals 10 and z equals 2. So I will substitute 10 in here, minus, and then parentheses. I'm going to open up another parentheses, 2 plus 2 squared. And so I get 10 take away, and I'm going to simplify. So 2 squared comes first on the inside to make 4. 2 plus 4, so it'd be 2 plus 4 is 6. So I have 10 minus 6, which gives me 4 as a final evaluated answer. I picked out this one especially because it is a fraction bar, and it has to the cubed power in the top. So when you make the substitution, okay, 3 to the third power divided by, on the bottom, 3 take away 1. What you need to do is you need to do all of the top first, and you need to do all of the bottom. So you want to imagine that these are each surrounded by big sets of parentheses. So 3 to the third power is 27. We've seen that from an earlier example. And on the bottom, 3 take away 1 is 2. So this is 27 over 2. That is a reduced fraction, believe it or not, as far as we could reduce it. But you could write it as a decimal, or it would be 13 and 1/2 as a mixed fraction. And for this one, use x equals 1 and y equals 1. So what we would do here is when we substitute the values in, so I'd have 1 plus 1 divided by 2 plus 1. So 1 plus 1 on the top gives me 2 over 2 plus 1. And so we would do this division first, and 2 divided by 2 is 1. So it comes back to 1 plus 1 equals 2. So I picked those examples because they specifically show us how to use how to do the fractions when you're evaluating fractions like this. So when you do have fractions like this, you need to make sure that you do all of the top and do all of the bottom and then divide the results, if it's possible. If you have variables on the top and the bottom still, you can't actually divide, so there's no use in doing that. Okay, so different types of expressions. I did want to also capture the idea that there are different types of expressions like square roots and absolute value signs. And so it is important for us to understand how to evaluate those kinds of things. So if I take the top one and I substitute a -2 in for y, so -2, there we go, times the absolute value of 6 plus z equals 6. And you're probably saying to yourself, well, absolute values always has to be positive. Well, so absolute value takes place in the p step. So we're going to take the absolute value of 6 and then multiply that result by -2. So the absolute value of 6 is 6. So it would simplify to -2 times 6. And then we're going to add 6 to it. So -2 times 6 is -12 plus 6, which is -6 as a final answer. Final evaluation. For this second one here, okay, we're going to substitute 8 into the top of the fraction and y squared into the bottom, and this is a double fraction. This is a complicated fraction, a complex fraction here. You'll learn more about complex fractions later in the year. However, I will tell you that you basically need to do all of the top and then divide it by all of the bottom. So I'm going to substitute this in, so square root of 800 over 8 divided by the square root of 9 squared. So if I'm going to do the top and then I'm going to come back to the bottom. So if I go ahead and simplify that, I get the square root of 100. So I have simplified it as much as possible. I did 800 divided by 8. That's where we want to start. When you have a radical sign, you want to try to simplify everything under the radical sign first. And then for the bottom half, okay, I'm going to take 9 squared, and that is 81. So I get 81 here. And then I'm going to go ahead and simplify these. So square root of 100 is 10 and the next square root of 81 is back to 9. And that's it. 10 over 9 is a completely reduced fraction, and so this is our final answer. For the third one on the page, we're going to do the same thing essentially here. Substituting a 4 in up here, and we're going to have to substitute 4 on the bottom, and we've got 5. Then we're going to have to substitute for w. So if I go ahead and I substitute 12 times 4 over 3, and then that is divided by the square root of 5 squared times 4. So let's simplify. The top, 12 times 4 is 48. So I've got 48 over 3. And this is still all over. 5 squared is 25 times 4. Should have been parentheses here and here as well. And then, so I'm going to go ahead and simplify the expressions underneath the radical signs. 48 divided by 3 is 16. And on the bottom, 25 times 4 is 100. So then if I simplify that, the square root of 16 is 4. And the square root of 100 is 10. And so we get a fraction, but this is not the final reduced fraction. If I check my factors of 4 and 10, I see that they both have a 2 in common. So we would reduce each top and bottom by 2 to get 2/5 as my final answer. Okay, one last page of these. So we're going to go ahead and do a couple more of these complicated ones, and then you see the featured one here. And the bottom one, I guess I forgot to add the use these things, so we're just going to skip it. For the first one, we're going to use g equals 4, so we're going to substitute in here square root, there we go, it's a little better. 4 squared times 4. And then we're taking the square root of all of that, and then we're going to square that answer. So we have 4 squared is 16 times 4 is 64. So I'm going to get under here 4 squared is 16 times 4, the square root symbol, squared. So I get the square root of 64 squared. So the square root of 64 is 8. So it's 8 squared, which goes back to 64. So you can kind of see that the square and the square root would have undone themselves. And for the last one, this one's the feature problem here. So if you understand this, then you're understanding what I'm trying to get across in this section. So I'm going to put in a 6, 3 squared with parentheses, negative 2 to the third, minus 2 times negative 2, plus 4 times 3. So, exponentiation first. 6 times 3 squared is 9. And then negative 2 to the third power is negative 8. Minus, so then I'm not doing any, and I haven't done any multiplication yet, I'm just doing all the exponents. I did only the exponentiation in this step. So now I'm going to multiply the results. 6 times 9 times negative 8. So I know that 6 times 9 is 54, and 54 times negative 8 is negative 432. So negative 432 minus, and so negative times negative turns into a positive, so it'd be plus 4. And then plus 4 times 3 is 12. So we're still going to get a pretty low answer here. Negative 432, you add 4 to that, you get negative 428, and then add 12 more to that, you get negative 416. So that's it, guys, for this video. And we learned that that expressions are multi-termed, and remember we're using addition, subtraction, not multiplication to separate the terms. Each term contains multiplication. Evaluation is to substitute and then simplify an expression using a given set of inputs. And there are a variety of problems now that we can approach using these order of operations skills. So that's it for today's video, guys and gals. Thanks for watching, and I'll see you in the next video.